There is something sitting inside your car right now that the dealership that sold it to you has never once mentioned, that your owner's manual glosses over in a single line of fine print, and that Japanese mechanics treat as basic knowledge so fundamental they consider it embarrassing that Western drivers have gone decades without it. It is not a feature you have to pay to unlock. It is not an upgrade. It is not something that requires a technician, a diagnostic tool, or a single dollar of investment. It is already there. It has been there since the day the car left the factory floor in Japan. And while you have been spending money on problems it was specifically engineered to prevent, it has been sitting dormant, fully operational, waiting for someone to finally tell you it exists. That someone is this channel. Stay with me, because what I am about to show you is going to change the way you think about your car permanently. Before we get into the specific functions, you need to understand something about how Japanese automotive engineering actually works, because it explains everything that follows. Japanese car manufacturers do not design vehicles the way most Western drivers imagine. They do not design for the showroom. They do not design for the first 3 years of ownership when the car is under warranty and any problem gets handled by the dealer. They design for what happens at year 8, year 12, year 15, when the car is out of warranty and the owner is entirely responsible for what it costs to keep it running. Every system, every hidden protocol, every embedded function that the engineers at Toyota, Honda, Mazda, Subaru, and Nissan build into their vehicles is built with that long timeline in mind. They know exactly what kills engines prematurely. They know exactly what drains batteries. They know exactly what causes the kind of incremental mechanical where that costs thousands of dollars in repairs a decade after purchase. And they built the solutions directly into the car. Here is what nobody tells you. Those solutions were never removed. They are still in there, right now, in your car. The reason you have never used them is not technical. It is commercial. And once you understand the commercial reality of the dealership service model, the silence makes perfect sense in a way that should make you genuinely angry. The average dealership service department generates between $4 and $6 million per year in revenue. A meaningful portion of that revenue, figures that internal service department analyses place between 20 and 30%, comes from repairs and replacements that the hidden systems built into Japanese vehicles were specifically designed to prevent. A battery that fails because parasitic drain was never managed is a $200 replacement sale plus a service fee. An engine with measurable camshaft wear at 90,000 miles because nobody demonstrated the cold start protocol is a repair bill that can reach $4,000 or more. A vehicle consuming 12% more fuel than its engineering allows because the efficiency management system was never activated is $400 a year in unnecessary fuel cost, year after year, for the entire life of the car. The dealership knows these systems exist. The service technicians know. The master mechanics who trained in Japan know. And the financial logic of never mentioning them is so clean and so consistent that the silence has lasted for decades without a single formal policy requiring it. It simply happens because the incentive structure of the service department makes it happen automatically. If this is the first time you are hearing this, subscribe to Secret of Japanese Cars right now, because this channel exists specifically to have the conversation that the dealership never will. Let me start with the function that Japanese mechanics call the most universally ignored protective system in modern automotive engineering. Every Japanese vehicle built in the last 15 years contains a battery protection mode that dramatically reduces the parasitic electrical draw that kills car batteries during extended parking periods. This is not a marketing feature. It is not something that appears in a specification sheet. It is an embedded protocol that the engineers designed to address a problem they identified during long-term ownership studies. Drivers in dense Japanese cities who park for days at a time were experiencing premature battery failure caused by the continuous low-level draw of electronic modules that never fully deactivate. The solution they built was elegant. A specific key fob sequence that triggers a deep dormancy state across every non-essential electronic system, reducing continuous parasitic draw by up to 60% and extending battery life across the entire ownership period in measurable ways. Toyota and Lexus owners activated by pressing the lock button on the key fob twice in normal fashion, then pressing it 2 additional times in rapid succession. A distinctly different confirmation tone tells you the system has entered Guardian mode. Honda and Acura owners hold the lock button for 3 full seconds after the initial lock sequence. 2 hazard flashes instead of 1 confirm activation. Mazda owners press lock once. Then within 2 seconds, press and hold the lock button again for 2 seconds. Subaru owners press lock, then unlock once, then lock again, all within 5 seconds, and watch for 3 hazard flashes as confirmation. For seconds, $0. And a battery that lasts significantly longer than one on an identical vehicle where nobody ever activated this function. The mechanic who sold you a replacement battery last year understood this system existed at the moment he rang up your $200 purchase. Now let me show you something that the engineers themselves describe as the single most impactful protective function built into every Japanese vehicle, and the one that Western market drivers use least consistently. It involves what happens in the first 30 seconds after you start a cold engine, and understanding it requires understanding something about engine lubrication that most drivers have never been told. When your engine sits overnight, the oil that lubricates every moving internal surface drains downward under gravity and pools in the oil pan at the bottom of the engine. The oil passages, the galleries, the channels that carry pressurized lubrication to camshaft bearings, crankshaft journals, cylinder walls, and valve stems are essentially dry at the moment of a cold start. The oil pump begins building pressure the instant the engine fires, but full lubrication pressure across every critical surface takes between 20 and 30 seconds to establish. During those seconds, every one of those surfaces is in direct metal-to-metal contact. The wear that happens in those 30 seconds is real, measurable, and cumulative. Multiply that cold start wear event by 2 starts per day across 10 years of ownership, and you begin to understand why Western market engines consistently show significantly more internal wear at 100,000 miles than their Japanese domestic market counterparts running mechanically identical engines with one critical difference. Japanese mechanics demonstrate the cold start protection protocol to every customer as standard practice. Here is what that protocol involves and why it works. After starting a cold engine, before placing the vehicle in gear or touching the accelerator pedal, press and hold the brake pedal firmly for 10 full seconds while the engine idles at its initial cold start speed. During those 10 seconds, the engine management computer detects the brake hold input and activates a cold start protection sequence. It elevates idle speed to accelerate oil pump output. It adjusts variable valve timing to reduce mechanical load on the camshaft bearings that are most vulnerable during low lubrication startup. It staggers the activation of accessory systems, including air conditioning compressors and alternator load, to allow the oil pump to build full pressure without competing electrical and mechanical demands. 10 seconds. Every cold start for the entire life of the engine. The difference in measured internal wear at high mileage inspections between vehicles where this protocol was consistently used and vehicles where it was not is significant enough that Toyota's own engineering data references it in internal training materials. The mechanic who quoted you $3,000 for a top-end engine repair on your 90,000-mile vehicle knows this protocol exists. Like this video if you have never been told this before, because the information gap between what Japanese engineers built and what Western drivers know is exactly the problem that Secret of Japanese Cars was created to close. What I want to show you next is the function that surprises drivers the most, not because it is technically complex, but because of how obvious it becomes once you see it. Every modern Japanese vehicle has a built-in diagnostic capability that most owners pay a dealership $150 to access during every service visit. It requires no tools. It requires no technical knowledge. It requires no appointment. It is built into the instrument cluster, and it has been there since the day you drove the car off the lot. For Toyota and Lexus models, turn the ignition to the on position without starting the engine. Press the odometer reset button 5 times in rapid succession. The display shifts into a system status readout. All zeros means every monitored system is reading normal. Any non-zero value points to a specific system that has moved outside normal parameters, which means you can identify developing issues before they trigger a dashboard warning light, before they become a diagnostic fee, before they become a repair bill. For Honda and Acura, turn the ignition to on and hold the odometer reset button for 10 seconds. The display cycles through a self-diagnostic sequence of every major monitored system. For Mazda, turn the ignition to the second position and press the odometer trip button 6 times quickly. For Subaru, turn ignition to on, hold the odometer reset, and press the trip meter toggle 5 times while holding. 30 seconds. No tools. No appointment. No $150 diagnostic fee for information your car has been generating and storing since the moment it left the factory. And here is where it gets serious, because the next function I want to show you is the one that Japanese factory engineers rate as the most consistently ignored efficiency system in any vehicle built after 2010, and it is costing drivers who do not know it exists hundreds of dollars every single year in unnecessary fuel consumption. Every Toyota, Honda, Mazda, and Subaru built in the last 12 years contains a real-time fuel efficiency management system buried several menu layers below the standard average MPG display that most drivers occasionally glance at. This is not that display. The standard average MPG display shows you a running average that lags reality by minutes and tells you almost nothing useful about the specific driving inputs that are costing you fuel. The hidden system shows you instantaneous fuel consumption updated 10 times per second. It shows you the exact fuel flow in real time as you accelerate, decelerate, and cruise. It shows you precisely how much fuel a specific braking decision or an acceleration choice or a speed selection is consuming at the moment it is happening. Toyota and Lexus owners access it by pressing and holding the display button on the steering wheel for 3 seconds while the standard fuel economy screen is active. The display transitions to the real-time flow meter. Honda owners with Eco Assist navigate to Settings, then Eco Assist Settings, and enable Detailed Coaching Mode. This activates a live scoring system that rates every trip on acceleration efficiency, braking smoothness, and speed management. Studies conducted on identical vehicles driven by identical drivers found that access to real-time fuel flow data changed driving behavior in ways that produced consistent fuel economy improvements of 10 to 15% within 2 weeks. On a vehicle that costs $2,000 per year to fuel, that is between $200 and $300 returned to your pocket annually, from a menu option that has existed in your car since the day you bought it, and that nobody at the dealership ever mentioned because your fuel bill is not their problem. If this is changing the way you see your car, subscribe to Secret of Japanese Cars and share this with every Japanese car owner you know, because the gap between what these vehicles are capable of and what their owners are actually getting from them is a gap that every dealership service department profits from keeping exactly where it is. The final function is the one I want you to commit to memory right now, not because it saves money, but because it could save your life or the life of someone in the car with you. Every Japanese push-button start vehicle has 2 different methods for shutting off the engine in an emergency while the vehicle is moving. Most drivers know only one of them. They know that holding the start-stop button for 3 seconds cuts engine power. What most drivers do not know is that this method also cuts power steering assist and power brake boost simultaneously, leaving the vehicle rolling under conditions where the steering effort increases dramatically and the braking system requires significantly more pedal force than most drivers in an emergency situation will instinctively apply. There is a safer method that achieves engine shutoff while maintaining full steering and braking control throughout the stop. Shift the transmission into neutral first, then press the start-stop button once. The engine shuts off immediately because the button press in neutral triggers an instant off command without the 3-second confirmation delay. But because the vehicle is in neutral, the drivetrain is disconnected, the vehicle continues rolling freely, and the power steering and power brake systems remain fully active. You steer normally. You brake normally. You guide the car to the shoulder under complete control and bring it to a smooth stop. Then shift to park. 1 second to learn. $0. The difference between those 2 methods in an actual emergency is the difference between a controlled stop on the shoulder and a loss of vehicle control at speed. A Toyota Technical Service Bulletin addressed exactly this distinction and was distributed to every authorized dealership in North America. The service advisors who took delivery training on that bulletin and then handed you the keys without mentioning it made a choice that their service department's financial structure made very easy for them to make. You now know what they chose not to tell you. The engineers who built your car spent careers studying what actually happens to Japanese vehicles over 15 and 20 years of real-world use. They saw the battery failures. They measured the cold start wear. They tracked the fuel consumption gap between vehicles using embedded efficiency systems and vehicles where those systems sat dormant. They built solutions to every one of those problems directly into the car at the factory level, at zero additional cost, requiring zero tools and zero technical knowledge to activate. And somewhere between the engineering floor in Japan and the delivery bay at your local dealership, that knowledge stopped traveling. Not because it was classified, not because it was dangerous, because a service department that generates $4 million a year fixing the problems those systems prevent has no financial interest in the 30 seconds it would take to show you how to activate them. You now have that 30 seconds. You now have the information. And every drive you take from this point forward can cost you less, protect your engine more, and put you in control of a vehicle that was always capable of exactly this. The dealership banked on you never finding out. Secret of Japanese cars exists because that bet should not keep paying off.